Hello everyone. Today we start a new topic of differential calculus, which is curve ratio. Okay, so first of all, we need to know the basic terms related to this. So one thing is concave and convex. Okay, concave and convex. So how can we define it? So let me draw a graph like this. If we have a curve like this, this is at a point P on this curve, and this is the another line C. It shows if P is any point on a curve and CD is any given line, given line, okay, which does not passes through this point, does not passes through this point P. Then the curve is said to be concave at P with respect to the line CD. If the small arc of the curve containing small arc of the curve containing P lie entirely within the acute angle between the tangent at P to the curve and the line CD. And curve is said to be okay. So what is concave? So if as you can see here, this is our coordinate axis, this is x axis, this is y axis, this is a curve, and there is a point P. Okay, so P is any point on a curve, and CD is any given line, which you can see this CD does not pass through this point. Okay, then the curve is said to be concave at P with respect to this line CD if the small arc of the curve containing P lies entirely within the acute angle between the tangent at P and the line. You know, this is the tangent and this is the CD. So if there is an acute angle, then this curve is known as concave. And if it is not, okay, the curve is said to be convex at P if the arc of the curve containing P lies wholly outside the acute. You can see here if we have like this and this is the curve like this and we have the line CD. Okay, this is the point. Now you can see this is the acute angle and this curve is outside the acute angle, so this is known as convex. Okay, if it is inside the acute angle, then it is called concave, and if it is outside the acute angle, then it is called convex. So I think it is clear to this graph is for convex, concave, and this is for convex. Is that clear? Okay, so let me move to next point of inflection. So a point P on the curve, you can see if we have a curve like this. Okay, this point P and this is the tangent that we, okay, this is C, into D, this is Q. We can see here at this side the function is concave and this at one side is convex and other side is concave. So a point P on a curve is said to be point of inflection. Inflection if the curve in one side of P is concave and other side of P is convex. With respect to the line CD, okay, which does not passes through. So the point P. So now how to calculate the points, the coordinate points of, yeah, how to find the point of inflection. So if we have a curve like, if we have a curve like this, okay, then we can say y equal to function of x. So to find the point of inflection, we need to calculate first derivative with respect to x, second derivative with respect to x, and third derivative with respect to x. Okay, so for this, put this one equal to 0 and find the value of x here, and after that check the value of third derivative. If it is not equal to 0, then these points are said to be point of inflection, otherwise not. Okay. If we have a function of x is a function of y, then similarly we can calculate dx over dy like this. Okay. Second derivative d2x over dy square. So, and third derivative is should be not. So this is the way to calculate the point of inflection of the curve. Is it clear now? Okay. So let us show one question. Find the point of inflection. Okay. And the curve is y square equal to x plus 1. Okay. So can we write this in the form of y? So yes, we can. So it will be y equal to square root of x times x plus 1. Yeah, we can write it x to the power 3 by 2 plus x to the power 1 by 2. Okay. Now, so it means we have y equal to x to the power 3 by 2 plus x to the power half. Now the procedure is same. Find the first derivative, then calculate the second derivative, put equal to 0, then calculate the points. Okay. So firstly differentiate with respect to x. So what we got here? dy by dx equal to half x to the power minus 1. Okay. Sorry. This is 3 by 2. So 3 by 2 x to the power plus half. And this is plus half x to the power minus. Okay. So now calculate the again differentiate. So what we get here? d2y by dx square equal to 3 by 4 x to the power minus half minus 1 by 4 x to the power minus 3 by. Okay. So now third derivative we also need. So third derivative will be this will be minus 3 by 8 x to the power minus 3 by 2. This will be plus 3 by 8 and it will be x to the power minus 5 by. Okay. For point of inflection, we have d2y by dx square equal to 0. So what we got? You can take 1 by 4 as common. So we got 1 over root x minus this is 1 over x to the power 3 by 2. This is equal to 0. If we take the LCM, so this is 3. Okay, so 1 by 4. It will come 3h minus 1 equal to 0. So 3x minus 1 equal to 0. We obtained x equal to minus x equal to 1 by. Okay. Now check whether the third derivative is non-zero or not. So we can see here, you can put the value of x at 1 by 3. So what you got here? It will be, we can take 3 by 8 as common. So minus of 1 by 3 give out 3 by 2 plus 1 by 3 give power minus 5 by 2. Clearly it is not equal to 0. Okay. So now We since point of inflection is of the form of ordered pair that is value of x and y. Now we can calculate the value of y here. Okay, so we can calculate from here. So we obtained y equal to plus minus 4 over 0. So thus the point of inflection will be 1 by 3 comma plus minus 4 over 3. Is that clear? Yes.